Hi, everyone. Thank you for joining us for our final session of day 3 of Azure Data Week with Mark Cromer, who is going to focus on data quality patterns in the cloud with Azure Data Factory. So without further ado, Mark, I'm going to let you jump right into your session.
Awesome. Thank you very much. Thanks, everybody, for joining. So as you heard, my name is Mark, and I am a program manager on the Azure Data Factory team. So the topic that I wanted to talk to you today about is data quality. So data quality patterns with Data Factory. And let me jump right into the slides. I'm going to spend the first couple of minutes here on the session, giving some overviews, a little bit of background on Data Factory and some of the things that we're doing here and how you can apply data quality patterns in the cloud using ADF. And then once I'm done with that, I'm going to spend the rest of the time on demonstrations, demos within Live Data Factory. So let me start here in terms of make sure that we're all on the same page in terms of what Data Factory is and what it brings to the table for you. So Data Factory has many different areas and components within it. The simplest way to think about Data Factory is it's an ETL tool. It's essentially the Microsoft Azure ETL service. So it's a cloud-first, serverless, platform as a service ETL service. That's service quite a few times in that statement. But anyway, you get the idea. So what I put on the slide is a couple of different screenshots from the different areas or different general sort of components within Data Factory. And there's a lot more to each of these, but we're only going to focus on just data quality today. But just so you have some ideas, so there's the orchestration piece in the top left where you build what we call data pipelines. And within those pipelines, you have actions and activities that happen. So you tell the Data Factory service what you want to do, and you schedule it for when you want it to happen. And then you set constraints and you set for loops and if then else's and those sort of workflow components. That's the left side. Sometimes, as I talk through Data Factory and through these slides and the demos today, if you're familiar with SSIS, some of these terms may be familiar to you, or other ETL tools for that matter. So I may sometimes try to do a translation for you. So think of the orchestration piece, what we call the pipelines in Data Factory. Think of those as control flow within SSIS, very similar. Next is the mapping data flows. The data flows piece is something that we added very recently to the product. We just went generally available with this feature this week, in fact. And we've had that in preview for the majority of this calendar year. So we have a lot of folks, a lot of customers using it. But data flows is what we're going to focus on today. So I'm going to use data flows to demonstrate to you how to build classic data quality patterns with your cloud-based data in Azure. And so data flows is, again, similar to SSIS, or what you think of in tools like Informatica in terms of data transformation mappings, things of that nature, where you build data transformations graphically. You visually build these. You define the intent of what you want to do with your data, and Data Factory will execute those in a scale-out cluster of Spark clusters for you. So you don't need to manage anything. You don't need to learn Spark or learn any coding. It's all code free. I'm going to save that. We'll be diving into that deep today. Right-hand side is Wrangling data flows. Wrangling is a different entry point for data flows. Wrangling is essentially the Power Query Online interface for data flows. This is in a limited preview right now. We're going to open that up a little bit more later this calendar year. We'll park that one for now for a different session. We can dive into that later. And then rich monitoring. So I'll be able to touch a little bit on monitoring. But the nice thing about monitoring is that's all part of the entire Data Factory chassis, that way. And it's the ability to introspect your pipelines, which includes depth of data flows. So as you build data transformations and then you execute those in orchestrated pipelines, you can then dive into the monitoring view to look at the execution plans of your data flows to see things like successes and failures. Look at the amount of time that each transformation step took in your data flows. We will give you information. We will surface you information about the partitioning of the data, because remember, data flows is, and really, to be honest with you, the entire Data Factory platform is built upon the idea of being able to scale out easily and natively in the cloud. And so we will partition data for you in Spark as you run data flows. You don't have to worry about it. You can turn some knobs. I'll show this to you today. So you can set partitioning, but we will surface to you what partitioning was used. And you can always just say, let that as default, allow Data Factory to determine the best number of partitions for my data. I'm going to do that for you too. Righto. So what are mapping data flows? If you're new to it, it's a newest feature added to Data Factory. It is the visual data transformation capability built within Data Factory. You do not need to ever leave Data Factory to build ETL projects. You can do it all within Data Factory. Now, that being said, we still also support coded and coded data transformation and activities. That's all part of the pipeline capability. Data flow is an additive new feature. And so I think I touched on most of these bullet points that we have on the slide. So let me just quick scan through these. I think we've got everything. There is an important feature down at the bottom left about resilient data transformations. We've built data flows as opposed to the way that data flows was designed and built for SSIS around a more traditional on-prem ETL, loading star schemas kind of model that is fully supported in ADF mapping data flows. You can do that, and we have a lot of customers doing that. Mainly with databases in Azure, of course, is the difference. But the key thing I want you to take away from understanding of data flows is that it was built with big data and data lakes in mind. So one of the examples I'm going to show you today around data quality is about fuzzy matching and fuzzy lookups, because it's important in data lake environments, because a lot of times the sources of data you're going to work with will not be as well curated or governed as they were previously in the on-prem worlds. And even in the on-prem world, we've always, those of us who've been in data warehousing for a long time, you'll all know as well, that wasn't always the case. And we had some struggles at times with customers who would have ETL patterns that would be somewhat brittle in terms of breaking. And so you had to be very defensive in building your data transformations to be able to protect against changes in data. And so we've built the ability to have resiliency in the data flows, not just restartability or checkpointing, but also the ability to work with data as it changes. The whole idea of schema on read and flexible schema. Actually, that was an easy way for me to say it without so many words, but there you have it. Alrighty, so at the end of the day, what you end up with is the left-hand side, you build a graph. So you gotta do, you build a graph, you design your logic, data transformation logic, you save it, you publish, you run it in a pipeline, and we will be able to send that payload. There's a script code behind on that graph, which is a script that gets sent to as a payload off to the Spark cluster. And we will execute that. And then we surface to you the execution plan of how that was executed. The right-hand side is what you have today in Data Factory. You write Python, you write MapReduce, Hive, SQL, procs, whatever you like, and you hand code it, and you run activities that perform that. The left-hand side is data flow. The right-hand side is activities within Data Factory. So the patterns that emerge that you can build directly in Data Factory are cleansing, aggregations, data conversions, prep, exploration. That's just a sampling of some of those. We're going to focus on the idea of cleansing and fuzzy lookups and things like that today. So this is not either or, this is and. So it's not mutually exclusive. A lot of pipelines of customers who are using data flows in Data Factory. I think I have a picture. I'll get to the picture in a second, but essentially they do all those things. They have multiple activities with data flows. So what's it going to look like? What you'll see this today is that as you build your ETL, you build your data transformations, you have a toolbox. Shouldn't be all that unfamiliar to you if you're familiar with other ETL tools like SSIS. One of the big differences in the design experience you're going to find in Data Factory as you build data flows and data quality routines is that this is not a floating toolbox that sits off somewhere separate from your graph. The graph is a construction paradigm whereby you're going to build your logic left to right, and you're going to add transformations with a toolbox as you go. I'll show it to you in a second. The middle picture that I have here is a look at the expression builder. So what we wanted to do with data flows and data factories, we really wanted to reimagine the way that we surface the function language within the engine to you. So the function language is essentially very Excel-like. So you see the functions on the right-hand side over here, the expression builder on the right-hand side. Now there's full IntelliSense available with it. There is essentially autocomplete. There's syntax checking, all that's built into it. So it's not a hand code some scripts, run your flow, come back and see what broke. Not trial anything like that. This is interactive. As you can see from the middle pane, you can see the data as you build your logic. you'll be able to see the data, and that way you can confirm the logic of your expression.
Hey, Mark.
Oh, yes.
People are asking if you mind just keeping your voice up when you talk. They're having trouble hearing you sometimes.
Oh, yeah, it's probably my microphone. My headset is a little bit old.
Okay, thanks.
Is this a little bit better? A little louder?
I think so.
Thanks. All right, let me just try to speak up to you. Let me go back. I think there's one more thing I wanted to say to this. No, I talked about being able to see the data as you build the expression. I think that I'll just save that for the demo. You'll be able to see that as we demo. Okay, so what do these patterns look like as you start to build them? So this is sort of the Azure data all up, what we call the modern data warehouse pattern. And you're taking data from the left-hand side. You are using Data Factory to orchestrate the ingestion of that data and the actions you take on that data. In this case, we're using Databricks for processing. So we're probably using facilities such as notebooks, or maybe some jar files or some Scala code, whatever. After we do that, so this could be your cleansing, could be through this mechanism. And then we land that data, that cleansed data, into a data warehouse, which is then available to your BI tools for reporting. Now, what changes with data flows and when you build your data quality this way is that you don't have an external compute engine to worry about. You build your data flows directly in the design surface of Data Factory, and then you let Data Factory execute those in Spark. So we handle the management of the Databricks cluster for you. You don't ever see it. You don't ever manage it. We spin it up and we tear it down. So it's very, very economical in that sense. You will not have a cluster spinning idle, doing nothing. We essentially handle the management of that for you just in time as a way to execute your ETL from Data Factory. This is the picture I was trying to get to earlier. Okay, great. So when you put this all together and you assemble your pipeline, this is a very common pattern that we saw emerge, which is that you will use a copy activity first to probably get some data from your FTP or from on-prem or Oracle or whatever it is. You don't always need this. There are several native connectors directly available to you from Dataflow that I'll show you. But this is very common. You'll take that data, stage it, and then you'll run your data flow routines. In this case, we're cleaning addresses, mastering customer data, very common data quality type of things you need to do with your data. When those are done, now you have the data in a curated form that you can then load your data warehouse. So we have facilities to load your star schemas, both dimension handling, so SCDs, as well as fact table loading within Data Factory and data flows. So you run that, and then when that is all done, you are signaling to Data Factory that's complete. My maintenance window is closed, and you will run your process models at the end. This is an end-to-end example, very simplified, but I think hopefully you're getting the idea of how all these different capabilities in Data Factory come together with data flows added to it. Let me see, I'm doing on time, 13 after. I'm doing pretty good. So for those of you not all that familiar with Data Factory, I want to level set a few terms as I talk through it and do the demos today. The first is that the pipeline is the primary component of orchestration within Data Factory. So you define a pipeline, which is almost like a control flow entity within SSIS, and you tie together your actions or we call activities that you want to have happen. They can be in serial, like you have here, with a precedence constraint between them, or they can be in parallel, in which case you just put them on the design surface at the same level without any connector between them. Each activity is each part of that pipeline, and they are activity types. There's three categories of activities. There's data movement, which is like copying data flow. The data flow is also transformation, so you see data flow falling into two different categories here. The hand-coded data transformations are the activities such as Notebook, HD Insights. We have batch for custom activities, custom code. We have, what else? We have stored procedures. Those sort of are the data transformation activities. And then the control flow activities. So there's actual control flow programming style types of activities as well. There's for each, there's if then else, and things of that nature. Data sets is very important. I want you to understand that to define your data within Data Factory, you must define a data set. Now, data sets within data flow, because we are very much geared toward the data lake and the nasty, gnarly kinds of data that you see, you don't always have to define a schema. You can say, I want to worry about the schema later when my data flow runs, and we have facilities to do that. I can show you some of that today. However, if you want to define a schema for your data set, so you can do that as well. So define a data set that defines the type and the shape of your data. Each of those data sets has connection information. The connection information that links back to your sources and sinks is known as a link service. So link service is based upon the type of data or the type of connection you're making, such as SQL Server, Azure Blob, ADLS, and those sorts of things. This is where you will store your credentials so that we can connect to your data. And then we have data flows. Data flows is what we're going to focus on today. This is the data transformation piece that you will graphically design and provide to ADF the intent of what you're going to do with your data transformation. Okay, oh, sorry, there's a few more. I forgot the other pieces. So triggers, very important to in operationalizing your pipelines. So in the demos today, I'm really going to focus on designing, building, understanding the logic flow of data flows and data quality. But when you get back home and you, I guess it's a virtual conference, so you're not actually going to drive home, but when you're done watching this video and you try this on your own, you will, when you get to the point of finalizing your design, and you go through an SDLC, a test dev test lifecycle, you will then operationalize your pipelines. When you do that, you will set triggers. Triggers are how you schedule your data pipelines in Data Factory. The different types of triggers are scheduling, which is a wall clock. So those of you familiar with SSIS, you would think of that as the schedule you set for your SQL agent. Tumbling window. So you can set windows of time, which you say, for example, every 15 minutes, I want to read in data within 15-minute blocks or windows of time. And those can go backwards in time as well. And then event-based, when a file arrives or a file is removed. So it's a good way, the event-based is a good way to set up a pipeline that executes when a file lands somewhere. You can use sort of a trigger or a control file. Just put a 1 0-byte file somewhere, and then when that happens, that will trigger a pipeline. Integration and runtime is the last kind of entity. So the other kind of entity that we're going to be using today are called integration runtimes. Integration runtimes essentially define, or in many cases are, a big important part of the backbone of Data Factory, if you will. So when you are moving data with Data Factory throughout Azure, let's say, for example, you have a SQL database, and maybe that SQL database is sitting in East US. And then in one of the central regions, let's say you have some blob store account, and you want to take some CSV files from a blob store account and move that into your SQL database. If you use data flows, or let's say more explicitly, let's say a different example, let's say using copy activity to move that data from central to east, you will do that on what we call the Azure Integration Runtime, which defines the location and defines essentially the compute within Azure that will be used to move that data. In data flows, you'll be defining the size and the time to live of the compute that you want to use for your data transformation. And then there's two other kinds of integration runtimes. We're not going to talk about them today. There's the on-prem, to be able to have a gateway that talks to your data on premises into Azure. And then there's also the SSIS integration runtime, where you can just lift and shift your SSIS packages directly into the cloud with Data Factory. All right, so last couple slides, and then we'll do demos the rest of the time. All right, so a couple of different data quality patterns we're going to talk about today. Don't be scared by the picture. I'm going to walk you through it. Data deduplication, distinct rows. Slight differences, slight nuances in these two different things. Data deduplication is very common when you're going to have lots of files landing in your lake. This is also a common pattern that you're going to see a lot of times when you're doing things such as migrating or conforming databases, and as well as conforming dimensions. And the other thing I want to show you on the screen is the middle picture The main picture in here is what a finalized dedupe with fuzzy lookup looks like in Dataflow. You can install this today inside of your own factory by going to the pipeline templates. So you actually, I'll walk you through this, but if you've seen pipeline templates before in Data Factory, if you go there, there's a category for Dataflow. And inside the Dataflow category are these patterns I'm going to show you today. So there's dedupe pipeline. I just realized I didn't put the distinct rows pattern out there yet. I'll do that after this call. Actually, I take that back. I probably won't get to it later in the week, but I promise to do it. Fuzzy lookups are very important from the perspective of when you have data that is not guaranteed to have gone through any kind of curation or any kind of governance. And you're going to find in many cases that names, for example, are not going to match exactly. So you need to use some techniques such as Soundex to be able to do fuzzy matching and fuzzy lookups on those. And here's how you can do it within Dataflow. And I'm not going to walk you through the picture. I'll show you the demo. That's it. I am done. All right. So I have some links, some important resources here in the slide deck. However, you're not going to be able to just click on those. So don't worry about writing these down. I'm sure that we'll find a way to get the slides to you all. I'll take that as an action myself to make sure these slides are available, and you can then get these links. If you take any of these down, the last one is the most important one. And I just realized I clicked. Oh my gosh, I'm sorry. Hang on a sec. This last one is the important one, which is the aka.ms/df links. In df links, I've put all of the data flow help that you'll need, guides, tutorials, blogs, labs. It should be everything you need, should be in there. Alrighty, so let's go into demos. Okay, so I'm in my Data Factory screen right now. Let's level set for those of you new to Data Factory. And actually, let me start from I'll leave this up. This is fine. So I'm in the design view for Data Factory. Now, when you're working with elements such as data flow, which is what we're going to be doing today, we're going to be doing data transformation. One of the first things you should do is click on the data flow debug. You see my data flow debug is not turned on. So what that means is I can't get that interactive experience and be able to debug my data flows. So I'm going to use my data flow cluster, and I'll show you that in a second how to set that up, which is an integration runtime. We're going to talk about integration runtimes. This will turn on my debug. So this takes a few minutes for that cluster to spin up and to become available to you. And when it is, then we'll be able to preview the data, and we'll see that light up. This will turn green, and then I'll walk you through the rest of it. So this is the design surface. Now, I'm in the pipeline view right now. This is the pipeline view. And these are all the activities that are available to you. There's the copy activity. There is data flow. And if you have some custom code, you can run it in the Azure Batch service. These are our Databricks coding activities. So if you have some notebook code, you want to operationalize that, and you want to execute that for Data Factory, you know that here. I'm not going to go through all the rest, but they're all in here for you. And this is how you build things and tie them together. So you can do things like you could have a copy activity for your data flow. So you can say copy some data into Azure. When it's done, run data flow. Once my data flow is done, let's go ahead and let's do something like refresh my analysis services models, and we'll do that at the end. So it looks something like this. Very, very simplified, but that's the idea. Now, each of these within Data Factory, we have a paradigm that we leverage quite heavily, which is the parameterized paradigm. So Data Factory fully supports parameters. What's very common to do is to create data flows and other activities that are generic. You can have parameters passed to it. So what you want to do as you build out these pipelines is to leverage parameters so that you don't have to hard code everything within each of these activities. But specific to what we're doing today with data quality, what we'll do is we'll take a look first at distinct rows. So you see that my data flow here would copy some, my data factory here would copy some data into Azure, would pull out just the distinct rows from that data, and then we would then signal that we're done at the end. So what you can do is on your data flow activity, you can see at the bottom, we have these settings. So we have the name of the data flow I'm running. All your data flows will show up over here on the left-hand side in the Resource Explorer. The category is data flows. And notice that these data flows are not tied to any single pipeline. So you can have a data flow that is reusable across any number of pipelines, And so what you do is when you add this data flow to any of these pipelines, you then say, I want to run the distinct rows data quality data flow here at this point. Now you run that on one of those Azure IRs. So I'm going to use my data flow cluster. My data flow cluster is defined. This is your compute for your data flow, and that is defined here in the connections. So when I go over to connections, I click on integration runtimes. This is where I will see all my integration runtimes, what we call IRs. Make it easier because integration runtime takes too long to say. So on my data flow cluster, this is the one I'm using. You will see that there is a section under here for data flow runtime. And for this, I have defined this to be a memory optimized compute type. So I'm assuming that when I use this, I'm going to have a lot of data transformations like aggregations, derived columns to create new values, a lot of compute in memory would be very useful for this data flow. So I give it memory optimized. I'm going to apply 64 cores to the job. So that'll give me 16 cores of a driver nodes, which probably end up being, could be 2 8-core VMs, or could be 4 cores. Not sure how that's going to divvy out, but I'm essentially saying this is the amount of compute I'm applying to this job. I have a time to live of 1 hour set on here. When I do that, that means that just-in-time stand-up of the cluster will happen just once, and the rest of the time, VMs will be available to be able to serve the rest of my data flow executions. All right, that's the underlying, that's the overview. That is what happens behind the scenes under the hood. So what do I do to actually build, and how do I get some data quality routines built within Data Factory? So let's go into that distinct rows first. So back to the pipeline. And this is the data flow that I added to my pipeline. Double click on it, you will go to the definition of the data flow. The data flow design surface is a little bit different than the pipeline, and a little bit different than you're probably used to in SSIS or Power Center or those sorts of tools, or maybe Talent as well. What we've done here is, instead of the traditional DAG style box and line, we have created a construction paradigm. So you build these from left to right, and what I have on the left, so my data flow cluster is ready. So my debug cluster is ready, and if you hover over, you can see that I'm spinning up my data flow cluster in the background. So this is ready to go to do data previews. So what you have now is, this is a fully built out distinct rows. This is the one that I will add to our templates. Oh, I forgot to show you that. I wanted to show you all that. So the templates, all of these patterns are available under pipeline from templates. Go to resources plus pipeline from templates. You click on the Microsoft templates and you click data flow. So there is dedupe pipeline. So you just give us your data sets, and we will add that data flow with a sample pipeline in your factory for you. We have fact loading, slowly changing dimension type 2. We have file operations, and a bunch of others. So these templates will install these data flows for you in your pipeline. So go to pipeline from template, select Microsoft data flow, and you'll get these templates. So this one is the one I'm going to add to the gallery. I'll add this to you probably this week or next week. I keep making it later. You notice that as I talk. But anyway. So the left-hand side with the vertical bracket, this is sources. So all your sources are added through clicking on Add Source. Because there is no floating toolbox or attached toolbox, this is how you create sources. You can create as many as you want. There is no limit to the number of sources that you can add. Think of this as an SSIS land. For those of you familiar with SSIS, think of it as almost like somewhat of a connection manager, in the sense that you can, that's not a great example, but essentially you create a collection of all the different things you're going to reach out to, so you can use them in lookups and joins and things like that. But here I have my source, which is a CSV. This is the movies database. I use this database all the time in my demos. If you watch any of the videos that I've created, you'll see that I'm using the movies database, which is the IMDb movies of with ratings and things like that. And the one that I use has some Easter eggs in it that makes it fun to look for certain patterns or things in the data, and also has some misspelled columns, so you can do things like you can correct the column names from file sources that have sort of data quality issues in it. And things like renaming columns is one of the most basic sort of things that you would do in a data cleansing sort of operation. So when you're in the data preview within your data flows, you can see the live data. So this is a look at the live CSV file that I have pointed to. The way I point to a CSV file is under source settings. I select a data set. These are all my data sets available to me in data flow. Data sets fall over under here on the left-hand side under Resource Explorer, under data sets, and they're all here. So you'll see the ones that are available to you in data flow right over here. Notice I have schema drift checked. Schema drift is that ability I mentioned earlier where we can take any changes to that data will still flow through your data flow. In fact, you can access it in your transformations, even though it's not part of my existing schema. So this under projection is the definition of my schema. And this is one of the things that always, this is little sort of pet peeves of mine, which is that Rotten Tomatoes misspelled in this file. It's Rotten Tomato. And so this is where you have the ability to fix that and do some data cleaning on that. So one of the ways that you can change that, this is the projection of the physical file. So you can't change it here. But what you do is you create what's known as a derived column. A derived column would change that. Before I show you that, let me walk you through the rest of this distinct rows, what this thing is doing. So distinct rows is going to find just the rows that are not duplicated within that data set. This is not joining with another data set. This is essentially implementing the self-join pattern. So to do that, I had to create two copies of the same source. You do that with clicking on the plus sign. The plus sign brings down your toolbox. The toolbox attaches each transformation, adds a transformation after that current step. So I did a new branch. New branch you can think of as, I believe in this we call it sort of multicast. It's that kind of a thing. It takes whatever is there at that point in your flow and it duplicates it. So now I have movie CSV here and movie CSV here. All right, these are both the same thing. Now what I can do is I can add to that what is known as a select transformation. So select transformation falls under the category of schema modifier. So this is metadata. This is essentially modifying your metadata. So I called it original data, and that's because there is nothing changed about it. Notice everything from the left is the same on the right. I am doing this because what I want to do is I duplicated my movie CSV. And so I want to give it a different name. The top row is the copy of the data called original data. The bottom row is the same copy called distinct rows. No difference. What I'm doing here is I'm just keeping exactly the same. But this gives me the opportunity to do something like, let's change this and fix this to Rotten Tomato. Now I feel a lot better about it, right? Now it's actually called the same thing. So that makes me happy. Now, if I go over to the rest of my transformation, I'm gonna leave this the same because I don't want to break this, the model I have. I'll go back to that later. But that's how you would change and fix bad columns that you see within your source data. Now, the last part of this top row, all it's doing is aggregating. And that's because I wanted to demonstrate to you how you can do row counts. So row counts is a very common thing to do in tools like SSIS. We would do this all the time in Pentaho and those sorts of tools, ETL tools. So what I'm doing is I'm creating aggregation. This is known as an aggregate transformation. The aggregate falls under the schema modifier as well. The reason is because the aggregate acts like a SQL select with aggregations in it. And so in this case, I am performing a count. And so as you know, if you're a SQL developer, you've written SQL in the past, when you perform operations like aggregations, you need to modify the schema so that everything is part of that aggregation schema. And so what happens is when you look at the inspect tab, there is a tab called inspect. This gives you the metadata, the names of your columns within your flow. All I have coming out after this is just the aggregation, the row count original. So all the other metadata, which was here, all the metadata from my source will be lost in my aggregation. So I just like to point that out. So what happens is when you do a row count, I can do a row count by saying, don't group by anything. I want all rows and just count one for each one of those rows and then see what you get. And so when you refresh this, unless I broke it with my changing my Rotten Tomato, what happens when you do that is you will get the count of every row within that stream. And so this is how you do a row count. So I'll let that bake, and then we'll show you the rest of this. So the bottom here is where I do the actual distinct So I'm using movie. Movie is my key column. And so I'm grouping by movie, and then I'm saying every time that we see a distinct movie ID, we're going to take the first occurrence of it. So when you do distincts, you need to make a determination of do you want the first or the last? And this is where you go into the expression builder experience within Dataflow. And you'll have the ability to do things like IntelliSense and use all of our different functions in the function language. So you say, do I want the first or the last? $$ is just part of our terminology that indicates that it is every matched column. Okay, so I'm saying the first of every column that comes in from my aggregate, I want to save just the first occurrence of it. So I made the call that for my distinct row implementation here, I want the first when that happens. So as we go back, we see the count from the top. The top is all original data. I had 9,128 rows. I run my distinct, so I only get distinct rows. And the count here at the bottom, which is the same row counts aggregation, we should see slightly fewer than that. While that is baking, there's something else I want to show you that's very important when you're using data flows and you are debugging. There's a debug settings button up here that allows you to change the row limits. We default the row limit to 1,000 so you get a quick experience. You may want to bump that up to a little bit more so you can get more rows in based upon the size of the data that you are debugging and previewing. So I have 2 duplicates within my data. And so now at the end of the day, I have 9,125. And then I'm going to land that. I'm going to put that all back into my lake. And I'm going to use a sync called folder out that will just output that data into a folder. And I left everything else exactly the same. So when you're here in your, this is an end-to-end data flow. This works just fine. We can save this. Now to test this, what you will do is you go back to a pipeline. So let's go back to that pipeline. I don't need any of these, but I did prove within my data flow itself that the logic is all fine. Everything's going to be working just fine. However, the data flow itself does not land any data in the sink when you're in the data flow. You have to use a pipeline to do that. So none of this data is being sent to this folder. To do that, I got to go into a pipeline. So in my pipeline, I am calling my distinct rows against my cluster, and I can go ahead and debug it. So click the debug button, and this will actually use the cluster that is opened already and started already, that's warmed for the debug cluster. So this will take 1 to 2 minutes, I think it'll take to execute this. And then, I probably should have opened this up earlier. I'll bring up my Azure Storage Explorer while I was doing that. I might just do that on a separate screen so I can multitask here while I was doing that. So then we can see the output of the file when it's done. So while that is happening, let me go into another data quality pattern. So that's a very simple distinct rows. Let's go into a, I'll tell you, let's take a look at fuzzy lookup, and then we'll do the dedupe pattern. So with this fuzzy lookup, I'm going to use the same movies database source. What I'm going to do is I'm going to show you that in this case, I receive, let's say, for example, in this case, I receive, let's say, multiple files about movies and their ratings as they change every day. I don't know if I'd get that every day, but let's say I get it every week or every month or whatever it is, okay? So this is the same movie CSV we saw before, and we see the data set points to the same one. Now, my vendors or my suppliers are providing me with a Parquet version of that file, and that's fine. Your sources can be any of these different types. When you work with Dataflow, the data becomes just data frames within Dataflow. So it doesn't matter to us. You can mash this up, you can join it, you can look it up, you can do exists across different types of data. It is all simply federated within this Spark environment. So that's all fine, okay? So the projection is a little bit different. The projection on this Parquet file has a lot more in it than the CSV does, all right? So what we're going to do first of all is I'm going to do what I call pruning. So I'm using my select again. Remember, my select is my metadata modifier. And I took off my least favorite column of all, my Rotten Tomato. And I took it off completely. So now, from this point on to the right-hand side of my data flow, I will no longer have Rotten Tomato. I'm a happy guy. Now, when I do pruning down the bottom, I only want these 3 columns. Title, I put it back here. I call it Rotten Tom, that's fine, and year. So I'm keeping year, but I'm calling it year 2, so it does not conflict with any year that is here within my top. All right, so this is combining these files And what we're going to do is we're going to combine them based on fuzzy lookup. The reason we're going to do fuzzy lookup is because the names have not been curated. This is some vendor that they have, some folks who type these in really quickly, or maybe they're scanning some documents and the names, the spelling is not always right. So I can join these together using a soundex. So you go into our expression builder, use this. It's this simple. You just use the soundex function. So when you look for functions in our expression language, you can search for them here, and it will give you help on it. Granted, that's not great help. We could make that one better, but we do have better help on some other functions, I promise you. And you can click on the expression reference stock at the top, and you'll be able to jump out into the entire documentation of all the Excel-like functions that we have within data flow for data transformation. All right. Okay, I got to hurry up because I'm running late. I'm running behind. So when you do a soundex now, what that's going to do is that's not going to join, instead of joining directly on two columns, it's going to do a soundex. So I'm soundexing both the left and the right, my existing CSV file as well as my Parquet file. And I'm doing equality joins, and I'm doing two of them. So this has to join on both the sounds alike title. This will be sounds alike, sounds like, as well as the exact year. However, I did have to convert. Notice my year coming from my CSV file, because of CSV, everything defaults to string. You can modify that, and you can clean that up by clicking detect data type. We will go and we'll detect the data types for you. I'm going to skip that and do it time. So I'm going to just do it manually here. I'm going to change it to an integer. Anytime you write an expression directly within a transformation like a join, this is an inline transformation. So this casting does not stay at this point, just so you know. Okay. So when we do that sort of a soundex, we can now bring together the data from those two without needing to have exact matching. The last thing I do is I filter. The reason why I filter is because I want to take out dirty data. Again, if you, I think I can show you this. If I go back to my source, my debug settings, I'll bump this up to give me 100,000 rows, so I make sure I get all the rows. When I do a data preview on here, there is some bad data in my existing CSV. I think I have a year that is negative 1980, and that's not a valid value. So in my filter, what I say is, I don't want anything that has null for title 2. That right there is a showstopper. Don't even bring that data in. So clean that up. And then if the year is great, the year has to be greater than 1900. Anything less than 1900 to me is bad data. So I'm just sending that out. This way it won't flow through. And you have some right there, negative 1980 is, I guess that's a setup. That's one of the Easter eggs, I guess I talked about. When I sync it, and let's do a refresh. Now, again, when you refresh and you preview data inside of data flow, it does not, my Azure Explorer is trying to come up over here on the screen. When you sync it, it does not actually land the data. When you are doing a data preview, all you're doing is looking at what the data would look like when you land it. So let me just go over back to my Azure Explorer. I'm trying to see if I can get the results of our previous run. No, I'll come back to that. But what you can see at the end of this data flow is I got everything together. I got the data from my Parquet file, which is the Rotten Tom, the title 2, the year 2, and I mashed that together. I joined it with my existing CSV, and you can see I don't have that negative 1980 here anymore, and I have a nicely spelled Rotten Tom, not Rotten Tomato, and I have all that together. So that is what the fuzzy lookup pattern looks like. There's a lot more detail to it. I do have a blog post on it in the links, so you can go to that. But I do want to go over and show you one more pattern before we close up. Before I do that, let's go back to that distinct rows pipeline. And that succeeded. It took 1 minute and 3 seconds to do it. So we can look at, let me first show you what the execution plan looks like. So this was a fairly simple data flow. So there's not a lot to look at, but if you click on the sync, you'll get the information about the partitions. Remember, there was, I think this data set has 9,000 rows. Actually, it's right here, 9,125. Remember, this is the distinct count. So it took out 2 duplicated rows. And then it gives you information about how the data was partitioned across all of the available partitions on the cluster for you. And it gives you information about essentially it'll find what looks like outliers. So this partition only had 31 rows in it, but none of this is anything I would worry about at all. Everything looks fine in terms of partitioning here. And I don't need to optimize this. I ran in a minute, so I'm very happy with that. Then you can see also the lineage of your data. So the there is my corrected Rotten Tomato actually, and you can see that it actually came from Rotten Tomato. So I had corrected that earlier. But you can see the source of all of this data as you write transformation. So for example, movie was mapped. is actually mapped for movies, so I didn't change that one either. So I don't have a good example in this one. Now these all match exactly the same, but the whole lineage of where your data comes from is shown to you in this view. And I think that's, and here's the time it took for each one. So notice the actual time it took to actually run through the transformations was only about 10 seconds. That makes sense because it's Spark and everything's in memory. The rest of the time was spent opening, closing, IO, dispatching that job to the cluster, executing it, coming back, and so on and so forth. I promise to stop a few minutes early so I can answer all questions, by the way. But I'm so excited about the stuff I'm showing you that I can't stop. All right, so last one I'm going to show you is the dedupe pattern. Dedupe pattern, now we saw some simple ones. Now we get to something that's very, very complex. And complex because it uses all the things I showed you and puts them all together. It has exact matching. It has fuzzy matching. Basically, this is the one that you can add to your pipeline from the pipeline templates. And then you can walk through and you can change it for your data. What I'm doing here, in this case, I have a different kind of data. I'm not using movies here. I'm instead using names data. So it has there's a data set that is a fake data set that has fake information about sensors. This must be people, right? So I believe there's demographics in it. Fake demographics. So let me increase the row counts, the row limit, so we get all of the data in. Let's take a look at the data. And as this is coming back from the cluster, I will walk you through what I'm doing. First, the end-to-end. This will take your source data and will take, in this case, it takes 3 different properties. It takes name, zip code, and phone number. So you see name, you see phone right there. Oops, where'd it go? There it is, phone right there. And you see zip, which is right here. So those 3 attributes, each one of those gets a score. So I apply, I think something around 25%, or I think it's like 50% for name, 25 for zip, 25 for phone, just to give you an example of how you can do this. You take those scores and you make a determination at the end. So here's your scoring right here. Yeah, it's 50 for names. If the name sounded like, it gets 50% likelihood of being a match, being a duplicate. If the zip is an exact match, so the zip and the phone are exact matches, the name is a SoundX fuzzy match. If the zip is an exact match, you get 25%. If the phone is an exact match, you get 25%. At the end of the day, what happens is you get 2 different streams. I use a conditional split here to say that if the score is greater than 50, say it's a dupe. If it's less than 50, which is everything else, this is a conditional split right here, then say it's not a dupe. And you land it in 2 different files. That's all you do. The rest of it, we can talk about some other times. I'm running out of time. Let's take a look at what the data looks like. So the data preview, I was back in the source, and my laptop is slowing down on me, of course. Every time I click, it's just taking forever. So be patient with me here. So here's a look at the data. There is, I forget where it is in there. There is something that, here we go. The Easter egg is Margaret Allen. So Margaret Allen has different employee IDs. Oh, these are employees. That's right. They're supposed to be employees. Same middle initial, same last name, same gender. The differences come into play when you look at their, I believe it's phone number and zip. Yep, phone numbers are slightly different, and the zips are the same. So let's see what this does with that at the end. So what you're going to get is you're going to get a score for each of these, and then you're going to get it falling into either the dupe row or the no dupe row. And let's see what we get. And then I'm going to stop there and answer questions. And I'm not going to wait for my Azure Storage Explorer on the other side. Yeah, that's fine. Okay, so it believes that 2 of these 2 Margaret Allens were greater than 50%. So it kept 1 and took these 2 out. So at the end of the day, it took out the 2 dupe Margaret Allens, and all you get in the no dupe is 1 Margaret Allen. And so that's how that works. So we're about 10 of, I don't want to overwhelm you with too much here because there's a lot of detail on this. And I think that the links that I have for you will give you better detail than I can on the call here. So with that, why don't we go over some of the questions?
Okay, great. Are there any limitations for running SSIS packages in ADF? Are every task and component supported? I'm thinking in particular about script tasks and script components or third-party components.
Yeah, pretty much that's all supported within SSIS. There's different ways to do some of those things. Like there's this, just got to make sure to check the right boxes when you stand up the SSIS integration runtime for third parties. So the way you'll lift and shift your SSIS is going to be through connections, integration runtimes, then you create a new lift and shift SSIS package integration runtime. And you want to go through all of these different things. So essentially everything should be supported there. There may be some things you have to do to point to file systems that aren't specific to your server's file system. But other than that, most everything will work.
Okay. What is the good best practice to manage the dev test qual prod credentials connection information?
Yeah, so the credentials, that's tricky. So there's two things I'm going to say that, because I should have said this up front, and I'm going a bit orthogonal on the answer, so I apologize for that, but it's very important. And that is that you saw me working here in this environment, and as I'm doing things like save. You will not get the save button in Data Factory unless you hook up your Data Factory to a Git repository. We support both DevOps and GitHub, but if you don't do that and you work directly from Data Factory, in fact, I have one over here that is connected just to Data Factory. When you work in that environment, what happens is that you don't get a save. All you get is a publish. And so every time you make changes, there is no, actually I had something to change. There is no save. There is just a publish that goes directly up against the service. So that's one thing. The second thing about the dev test prod is that there are credential changes, right? So in that case, you have to have linked services and data sets that point to those sort of dev resources. The easiest way to do that is essentially through ARM templates, or if you're doing it through GitHub, what you have to do then is you have to change out the data sets and link service that you're using. A lot of the data sets that we have in Data Factory, we are adding capabilities to have more link service parameterization for that, so it's going to be easier in the future. The other thing I wanted to say to that, I lost my train of thought on that. I think we'll just leave it at that. We have essentially what I would do in that case is, yeah, the import export is one way to do it. If you're using GitHub, then you have to have the different link services that point to your different dev and different prod resources. I know what I was going to say. Here it is. When you're debugging in Dataflow, the one thing you can do though is if this is pointing to a data set that connects to a live production database or file, you can override that in debug. So where I was before in debug settings, there is the ability here to say that I want to just test against a single file. So I can see my movie CSV is actually located here in my staging or my non-prod blob store. And you can do that here. You can even upload a file from your laptop. So you can override that connection to your live system to do testing against non-prod that way.
Okay. So the method you said to kick off is a file drop. Can we not make a REST style to kick off an ADF?
Yeah, the kickoff point, if you think about it that way, how you actually execute things in Data Factory is always at the pipeline. So all those entities I talked about earlier within the entity sort of object model of Data Factory, pipeline is that entry points. This is what kicks off everything. And so these are at REST point addressable. You can use PowerShell, you can use the REST API, and you can execute these pipelines from a REST endpoint.
When you run ADF in debug mode, does it write to sync?
No. So the way you write, so this is all when you are, actually, let me step back. I want to be clear about that. So when I'm here in the designer, this is the data flow designer, and I'm in debug mode. When I'm doing data previews, I'm looking at my data. Let me go back to my fuzzy lookup, for example. And I'm here on my sync. When I did this data preview on my sync, this didn't write any data. This is a snapshot of what is in memory at that time within the data frames within your Spark cluster. Whew, that was a mouthful. It is essentially a sneak peek. This is not writing any data. To write the data, you go into what I did earlier, which is go to the pipeline itself, add that data flow activity, here, click debug here. So this is pipeline. This is the pipeline designer. You can tell it's the pipeline designer because it's the traditional sort of box and line thing, right? Not the construction thing. You go into here and you click debug, and now it'll run this up against the live data, and it will also land the data into the sink. So this is where you can go and look at your execution plan. And then, in fact, I think what I can do is while I'm answering other questions, I can show you that my Explorer, oh, hang on, I'm just gonna close this. My Explorer did finally come up, so I can bring that back over here. I clicked that by mistake. And I go, wait a second, I'm gonna go over this, there we go. If I go here, you will see that in the, oh yeah, you don't have to reconnect. I can't show you the file, but this will write the file to your blob at that time. So yes, this is where it writes files when you go to debug in the pipeline.
Okay. Is it possible to run multiple instances of a graph?
Let me think if I can understand the question. So there's two different kinds, let me answer it this way. There's two different kinds of graphs in Data Factory. There is the pipeline graph and there is the data flow. The pipeline, you can run multiples by just having different layers, right? So I could have a web down here. I could have a data flow here. I could have something else in here. I could have a notebook here. These would all run in parallel. You could have you can execute the entire pipeline itself as well parallel by using the execute pipelines. The execute pipeline activity lets you implement sort of the child parent pattern, which is quite popular in SSIS control flow. And then this could have multiples of these at the same level as well. So these could all run in parallel. On the data flow side, these all run, it's not necessarily deterministic. So what happens is if you look at the code behind, this is the JSON that defines your graph. And then you click on the plan button. This is the script behind. This is what defines the transformation. So the actual data quality transformations we're doing is all defined in this script right here. This gets shipped down as a single payload to our executor running on Spark. And then we can determine whether or not it's best to run these in parallel or as a single serial units. In fact, we can even rewrite the query. So we can do things like if you have something silly like, where's my fuzzy lookup? Yeah, my fuzzy lookup, I have a filter all the way down here at the right. If we determine that this filter can be pushed down, folded into that source, we can rewrite this query on the Spark side to actually put that filter way up here on the source. Anyway, I think I kind of went way around the answer to that, but it was a little bit of a tricky question. So hopefully you got some good info on that, but yeah, I'll probably leave that one there.
No worries. Well, that was the last question. So I think we have like a minute and a half left. So get on timing. Yeah, so Mark, thank you so much for a good presentation. Thank you everyone for all your questions. And we will see you tomorrow morning for the last day of Azure Data Week. Mark, thanks again. We always enjoy having you.
You're welcome. Thank you.
Have a good one. Bye.